Thank you for the, good morning. Thank you for the invitation to participate in this session. In 4 minutes, really, there's only time to discuss one idea, which is what I have here in one slide. So I want to briefly highlight what I've titled here, the unresolved Southern Ocean problem, the seasonal cycle of CO2 fluxes in the Southern Ocean. So this is a problem that I worked on for my PhD. And my PhD program, and I've moved on to do a postdoc working on a different subject. And I've recently started at CSR really looking at one of the things I'm doing is to really look at this problem from a different perspective, So what I want to do here is I just aim to really highlight this issue and draw one thesis from it. So, and to really highlight what I'm really talking about here is that state-of-the-art system models still have a poor skill in resolving the seasonal cycle of CO2 fluxes in the Southern Ocean. Now, and so to highlight this, I show this is a suite of 10 CMEX6 models. So this, you can say these are state-of-the-art assisted models. And in different colors, and in black are observed estimates. So these are data products, essentially. So our best estimates for observations these are data product based on observations. So they give us the best estimate for observations. So the figure in the x-axis is essentially time. So starting from February to July, the last 18 months are repeating for visual purposes. All right. So if you look at this figure, and so you have these 7 sectors of the ocean. So if you look at everywhere else except the Southern Ocean, you see that the models generally agree in terms of what the seasonal cycle should look like, what it looks like. And this is compares well with the observed estimates that we have. And, although there are other parts of the ocean, like, the North Pacific, for example, where you have the model overestimating the magnitude as far as the observations, as far as the observed estimates are concerned, but the phasing is similar, which says something that the processes that are dominating seasonal variability, they are captured. The magnitude might be wrong, it happens in models. But when you look at the Southern Ocean, the models disagree. Essentially, if you look at, for example, in the subantarctic zone, like you have 3 classes of models, which all of them disagree with the observed estimates. So as much as you can, one can agree whether the observations are right, it's a fair point. And this brings to my first. So I want to draw 2 theses from this. The first one being, a need for for observations, really, in acid flux observations at a finer scale. So at the final scale, which is high temporal scale, but as well as large temporal scale. So covering months that we need, like winter, where we have very limited observations. That there's still a need to resolve this problem. And the second thesis is that the fact that we're still unable to resolve this problem. And so these are system models, but even when you look at ocean-only models, and very fine scale resolution models, we still are unable to resolve the seasonal cycle. So it says something about it's possibly something that we don't understand, or we don't understand well enough. So we really there is a need for further understanding of what's really going on and how do we model. So it's not clear whether it's insufficiency of understanding or it's a model problem. It's an inability to model the seasonal cycle the way that is. And so this is an open problem. And this is, part of the work that form part of the work that I'm doing at CSR. And I hope that in the next, soon, I'll be able to update and to push forward in resolving this problem, both from the observations perspective as well as from the modeling side. Thank you.